We're live. This is Math 40 Elementary Algebra, and that is the gardenia that just grew in my garden. And it's covering up the fact that the ring light just wants to reflect today. So it's a very shiny place today. But what we're going to be doing is solving equations using properties of equality. Woohoo! Yay! So I'm going to approach this material as if you've never seen it before. So some of it may feel a little bit slow. And the goal would be that we build a really strong foundation. And so when we really get going and do some of the really cool stuff we're going to do with equations, that you will have that solid foundation to build upon. So we're going to start off with something that maybe is a little weird. I want to talk about true and false equations. So, for example, I could tell you, because you can't see me, I could tell you that I am a giant lizard that just crawled out of the ocean. I could say, I, Catherine, am a giant lizard that just crawled out of the ocean. And then you could decide whether that seems reasonable or not. Given that I have somewhat pinkish brownish hands, it seems unlikely that I'm a giant green lizard. I could be wearing, I guess, people gloves. I don't know. But that's a false statement. I am not actually a giant green monster. In fact, math can also lie. So let's take a look at these. The first one says 3 plus 4 equals 7. Is that true? Yes, it is. That is a true statement. Yay! Then the next one says 3 plus 4 equals 8. That is not true. That is false. And let me point something out just because I'm in that kind of a mood today. Can I note that 3 plus 4 is not equal to 8 is actually true? So I can take that equation, 3 plus 4 equals 8, that's false. But if I put across this line through the equals, it means not equal to 8. So it's just kind of interesting. We can play with truth. There's actually a whole branch of mathematics called logic that is really cool and deals with things like this. But I'm going to go on to number 3 because this is a really interesting situation. I'm going to say x plus 6 equals 10. Now, x is intended to be probably a variable. Maybe it's even a constant in this setting. We don't know. But is this true? And the answer is this is only true some of the time. If x represents the number 483, this is not true. However, if x represents the number 4, 4 plus 6 would be 10. That would be true. So this is a sentence or an equation that is true sometimes. And that is what makes algebra, solving equations in algebra, a little tricksy, is that the equations are not just obviously true or false. They are sometimes true. And so what we're going to spend most of chapter 2 doing is figuring out how the heck will we know when it's true. So the first question, the first example is determine whether 4 is a solution of this equation. So if I've got x plus 6 equals 10, and I want to check x equals 4, do you guys know what I do? And of course you can answer the screen, and I can say you're right. I take the spot where the x was, and I stick in its place the 4. Now, the way I learned to do this is you don't just say it is true, you put a question mark. That was how I learned to do it back in the Middle Ages. And here, let me bring this guy back in. It isn't necessarily the only way to do it. There are a lot of ways to do this, but I was told to put the question mark there, and I like it because it reminds me, I'm not saying it's true, I'm saying, is it true? It's still a question. So I'm going to look over here and I'm going to say, okay, 4 plus 6, well, that's 10. And I'm going to say, whoa, it was supposed to be 10. The two sides are equal. or they match, that means the equation is true. The other way we talk about it is we say x equals 4 satisfies, which is kind of a funny, oops, satisfies, I got ahead of myself, satisfies the equation. Which it's a funny word to use because I think like satiated, when you're satisfied, it's like you've had a really good meal. So the equation 8x equals 4 and was full. Not too full, not too hungry, just right. This is the middle bear, I guess this is the baby bear that was just right. So x equals 4 satisfies the equation. And so we would say, yes, this is a solution. X equals 4 is a solution to this equation. So there's a lot of language we can use to describe what's happening. And I wrote all of these things out because you're going to hear these in various ways from various people. Everyone has a different style. So that answers that question. The next question you might ask me is, well, if this is a solution, does that mean there are others? And the answer is, wouldn't you like to know? And if you ask me, then the answer is yes, you would like to know. And I will say no. This is the only number that satisfies this particular equation. And I know that for secret reasons that I'm about to explain to you throughout the rest of the chapter 2. So let's get to the rest of chapter 2, which involves, as you might have guessed, superheroes. Yay! No expense is spared when I'm preparing for these videos, as you can tell. Here I've got Loki, the Norse god of chaos, I think. Oh, I'm sure you guys are throwing things at the monitor right now. I'm sure I got that wrong. And his brother Thor, famous from the movies, but also from mythology. So we've got Loki and Thor. There's Thor's, the red thing is his cape. And as it turns out, despite the fact that they look really different in the movie, I looked it up, and the two actors that play Loki and Thor are actually about the same height. So they're about the same height. So we're just going to assume that the height on both sides, same height. Height, one of the hardest words in the universe to spell. I'm going to refer to Loki as X. I'm going to refer to Thor as Y. And I'm going to say X equals Y. So far, so good? Okay. So then, I wasn't kidding. I did prepare. Handmade. If Loki and Thor stand together on a box, they're still the same height. So I'm going to put them up on a box. There they are standing on top of the box. Are they still the same height? And the answer is, yeah, they still are. They're still the same height. Now, their height is higher than it was when they were standing on the ground. Obviously, they're a lot taller now, but they're the same height as each other. Now, if I say that this right here has a height of C, let's say that's C tall. And remember, Loki was X and Thor was Y. So Loki is now X plus C. And Thor is now raised up, so he's Y plus C. This is called the addition property of equality. This says that I'm allowed, if I have X equals Y, I'm allowed to add C to both sides, and it doesn't change the fact that they're the same height. They're still the same height. I raised them up the same amount. Now, what if I raise them up a different amount? If Loki gets to go up really high or Thor doesn't get to, or the other way around, well, then they're not the same height anymore. As long as they both get raised up by C, they're still the same height as each other, I should say. Okay, what if I put them in a ditch? Well, they're gods, so this seems like a bad plan, but I'm going to do it anyway because I'm a mathematician and, you know, we're not scared of anything. If I put them in a ditch, and let's say the ditch is also, it's poorly drawn, but it's meant to be the same height as the box. Let me put the bottom on this box. There we go. Box. And this is a ditch. So now, if I measure their height from the ground level, they're shorter than they were, right? I wasn't kidding. I really did prepare for this. I made a billion of these little guys. They're not as tall as they would have been standing on the ground. They're a lot shorter. However, they are the same height as each other. And so what is going on here? Well, what's going on here is, remember, Loki is X and Thor is Y. So Loki is now X, but he's not X high anymore. We subtracted C. We pushed him down C. So he's C shorter. And I claim that when you do the same thing to Thor, so you get the minus C on the right and the minus C on the left, the equation is still true. They're still the same height as each other, as long as you do the exact same thing to both sides. And this is called the subtraction property of equality. Addition property of equality, subtraction property of equality. Okay, next one. Next one gets a little weird. If you clone them, so in other words, you've got a bunch of them running around and you stack them up on each other. So I only have room for 2 stacks. So I cloned them. So now I've got 2 Lokis and 2 Thors. The piles are still the same height. 2 times Loki is equal to 2 times Thor. Another way to look at it is I could take C times X, and that would be equal to C times Y. Because if I had more of these, and I only made a few of these, but I could keep stacking them, and the 2 stacks would stay the same height, because each of them has the same height, then another one same height, another one same height, etc. Now, there's one thing that I will note. Here, it would be true, but notice you don't want to have 0, because 0 means you get rid of everybody. So be careful when you multiply both sides of an equation. Don't multiply by 0, because then you have nothing left. And then you've got 2 really fierce Norse gods pretty mad at you because you've disappeared them. You know, and they were expecting to star in the movie. So this is called the multiplication property of equality. So far, so good. I can move them around however I want, and I end up with the equation continuing to be true. Now, again, are these numbers on the left and right the same number that were here? No. These are new numbers, but they're equal to each other, so the equation stands. The equation is still true. Is this still true? Yes. If these match, then this is true. Are these true? Yes. If the numbers on each side match, then those are true. So now we get to a weird one. This one I have never, in my 400 years of teaching, I will make pictures of that. But in my 400 years of teaching, I have never figured out how to do a drawing of this. So we're just going to have to imagine the division property of equality, because you can imagine this would be kind of a gruesome thing to talk about. So we're not going to talk about that. Thor and Loki are just sitting here listening in, and we're going to be like, no, we're not. We're not going to talk about, dividing you up. But could you believe me if I said X over C would equal Y over C? If X equals Y, then if I divide both sides, each side by C, I would get a true equation. And I know some of you have done this before, so I know some of you are like, oh, wait, I know. You better not let C equal 0. Yeah, you can't divide by 0. Don't divide by 0. Don't divide by 0. When we write something like don't let c equal 0, we're just kind of giving a warning. It's kind of like one of those signs where it's like don't touch this, there's a lot of electricity, or don't try to, I don't know, don't try to, I'm in a blank. I have no idea. I can't think of anything that would be as bad as dividing by 0. So you will have to use your imaginations. But I can divide both sides of the equation by any other number and get a true equation. That's really cool. And that's called the division property of equality. So what is the bottom line? The bottom line is if you start out with truth, as long as you do the same thing on one side that you do the other side, you will continue to have truth. Unless you do something so weird that it blows the whole thing up, like dividing by a 0. So we're going to use these properties, and we're going to use them to go into figuring out what the answers are to equations. So in other words, I'm going to skip this, come down here and show you. I'm going to give you an equation like 5 times t equals 40. And I want you to tell me when would that be true? And if I just try random numbers like 5 times 1, that's 5. That's not 40. That's not true. Okay, 5 times 2, that's 10. That's not 40. That's not true. It could take us a long time to try all the possible numbers to get an answer. So what we're going to do is follow this very simplified list. Now, I know the book that you're reading has a much longer, more complicated list. This is my list. So first off, locate the variables. There might be more than one. And then decide which side you'd like them on. I am a big fan of choice. You can put them on the left, you can put them on the right. It does not matter. Use addition and subtraction first to quote unquote move terms. You're not really moving the terms, you're adding and subtracting. But once we get there, I'll show you that. So that all the variables are on one side. This is incredibly important. You want to get the variables all on one side. And then move all the constants to the other side. Then use multiplication or division to isolate the variable. Now, what does the word isolate mean? And again, you guys are not here. If we were in a classroom, you'd all be yelling, we know, and I'd be saying, okay, yeah, you tell me. So isolate means to get the variable all by itself. Okay, let's give it a try. Woohoo! You guys ready? This is algebra. We're in it. This is the big leagues now. Okay, so I've got 5t equals 40, and I want to isolate the variable. I want to get it by itself. So locate the variable. It's right there. Decide which side you'd like them on. It's there. It's on the left. I'm going to leave it on the left. Do you want to put it on the right? Go for it. As long as you follow the rules, the properties, you can put it literally wherever you'd like, really and for true. Some ways are going to be harder than other ways, so I'm going to try to show you which make the most sense. But, the best way to learn something is just to try different things and see what works and what doesn't. So, have a big math party. Have all your friends join you. Hey, guys, let's solve equations. Oh, yay, that sounds like fun, Bring out some Doritos. You're guaranteed fun times. Even if you're quarantined, you could do it over Zoom. We could have a Zoom math party. I know all the kids are doing that lately. Okay, step 2, use addition and subtraction to move terms so that all the variables are on one side and all the constants on the other. Well, the t is over here by itself with a 5 and the 40 is on the other side. I don't need to move any terms. We're okay there. Use multiplication or division to isolate the variable. So generally, what you want to look at is you want to look at what's actually happening and do the opposite thing. So what does that mean? Well, this is 5 times t. Remember, we've got that implicit multiplication. We write two things right next to each other, they become multiplication. That's how the shortcut for multiplication is. If this is multiplication, I want to undo that by using, you got it, division. So what I'm going to do is I'm actually going to rewrite this over here so I've got space. 5 times t equals 40. On the left, I'm going to divide by 5. On the right, I'm going to divide by 5. Just like this. Divide on the left by C, on the right by C. I am not dividing by 0, so we're good. And then, look at this. This is very exciting. The 5 cancels. Woohoo! Over on the right, the 5 also cancels. And it leaves 40 divided by 5, which is 8. So then I get T equals 8. Now, it did not say we need to check these guys because we're just trying them out right now. We're just kind of learning. But we could check it. What does it mean to check? Well, it means you take your equation, 5t equals 40, and in place of the variable, I'm going to put the answer I got. I'm going to put, because I do this, the question mark there. Does 5 times 8 equal 40? Yeah, it does. Woohoo, the two sides match. It checks. Now, I draw a little check. It's kind of a little joke because this is called a check mark. So I've checked. See? I know, mathematicians, we are hilarious. So that's a check mark, or you could put a happy face, or you could write woohoo. Make sure you make a note. If it doesn't check, you need to say something. You need to say, oh no, it didn't check, or oh gee, golly gee, we should do the problem again, or something like that. Okay, so let me kind of make a little space here. We've got another problem to do. I know you guys are excited. You were like, oh no, we're out of problems. No, we've got another one. We've actually got a whole stack of them, you know, I'm all ready. But for this video, I think we've got one more, and then we will continue on in the next video. So for this one, my W is over here on the right. I personally am totally cool with that. If you do not like that, add 5W to both sides if you'd like. You could do all sorts of interesting things. I'm going to leave the W on the right. We're just going to take a deep breath and go, okay, this will be okay. And I'm going to take a close look at what's happening. I've got a -5 times W. So this is a -5, and I've multiplied times W. I want to isolate W. So what I want to do is get, because there are no other W's, I should double check. Are there any other variables? No, it's just the one variable. Sorry, I didn't go through the steps. The variable's here. There's only one variable. We're good. So let's use multiplication or division. I'm going to use division because I've got multiplication. So I undo that with division. So I'm going to take the -80, and I'm going to take the -5 times W, and I'm going to divide both sides by a -5. Now I need the Bat Brothers. They come flying in, flop, 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 flop. And boy, are their arms tired. I'm going to leave them right up here for a moment. Okay, so over here, the -5 and the -5 cancels completely. And I'm just left with that W. But what happens over here when I cancel? Well, remember, if I've got two minuses, a minus over a minus, right there, minus over a minus, it makes a plus. So a minus over a minus makes a plus, just like a minus times a minus makes a plus. Two minuses, the Bat Brothers, we got a plus. Woohoo. So -80 over -5. You could even use your calculator if you're not sure. Not everyone has this memorized. That's okay. Remember, when we're doing negatives, a minus sign in front of a number, don't use this. It'll confuse everybody. Well, it won't confuse me, but it'll confuse the calculator. Make sure you use the special negative sign. So -80 divided by -5 gives me 16. Woohoo! So over here on the left side, I've got a +16, because again, negative over a negative, I get a +16 equals W. Now, if 16 equals W, do you believe me that W equals 16? This is another property of equality that says if two things are equal, you can write them in either order. If 16 is W, W is 16. Kind of woohoo. Okay. And then if you want to check, we can check. I know everyone's like, check, check. Yay, let's check. So in place of the W to check, we're going to plug in. The other word for that is substitute. Question mark. Right there in place of the W, I'm going to write the 16 on my calculator. -5 times 16 equals. Over here, I've got -80. They match. It checks. The world is beautiful and perfect. Loki and Thor wave goodbye. Goodbye. And I'm going to say, woohoo, you guys did great. We're going to continue on in the next video. We're just going to do a whack ton more of equations. So we'll get more practice. Woohoo. So I'll see you in the next video. Woohoo and math on, guys. Math on.